Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
Hello, this is Dylan Martello from our Buildings and Beyond team. On this episode, we are talking about acoustics in buildings, and in particular, this concept of room acoustics. Now, I'll get into what I mean specifically by room acoustics in a bit, but before getting started, I wanted to tell you a little bit about our guest, Graham Wax. Graham is the owner, founder, and lead acoustical consultant of Music City Acoustics in Music City, Nashville, Tennessee. Graham and Music City Acoustics specialize in improving room acoustics in projects across the U.S., working primarily on recording studios, offices, public gathering spaces, and places of worship. He's been on this journey of improving room acoustics in buildings for over 10 years, and we're excited to share with you his experiences and perspectives on acoustics in this episode. Now, I am sitting here with fellow Buildings and Beyond host Robb Aldrich in the conference room of our Connecticut office, and we're here to provide a little show and tell before getting into my interview with Graham. In this, you'll be able to hear the difference between a properly acoustically treated office conference room versus an untreated one. Robb, thanks for joining me today.
Right on.
So how often do you think about acoustics when you're in an office? Or how often does it come up?
I mean, it comes up when it's bad, really.
Yeah.
That's so if I can't hear somebody else talking to me, I mean, like in restaurants or something, it comes up all the time.
Right,
when
right.
you're yelling to somebody across the table. In an office, it's not that bad, hopefully.
Right, yeah.
But there are still instances where, you know, I mean, we have kind of an open cube area in our office here, and if somebody's talking in the kitchen, you can hear their voice echoing all throughout the office.
Right,
It's less than ideal.
Overhearing their secrets and conversations.
Yeah, right.
And how the weekend was.
So I think about it when it's bad.
Yeah.
And I don't think about it when it's not bad.
That's such a good point. I think that is what, we'll talk about in this interview with Graham. So much of room acoustics is dealt with dealing with problems as opposed to planning for them in advance. It's usually, hey, we have a room and the acoustics are really bad and we need to fix it. And it's funny because that's really the situation that we're sitting in this environment right now in our conference room in Connecticut. You know, we have this room, is a typical conference room and has webinars and discussions and speech intelligibility. The concept of understanding what people are saying is so important. And what's nice about this is we have a good comparison room as well where we eat lunch, and it's the same general dimensions and construction type as our conference room, and that room was not acoustically treated like our conference room here in Connecticut was.
Yeah, and it'll be interesting when we go to your interview when you and Graham are both sitting in more studio.
You're right, recording studio grade acoustics.
Yeah,
You'll
right.
hear the difference of really bad acoustics, particularly room acoustics, good room acoustics in a conference room setting where there's still some echo, and you can probably hear that now, and then like an environment where there's no echo or no what we call reverberation, which is really one of the key concepts of room acoustics, and that's how long it takes for a sound to decay after it occurs. So,
and this room has, we have 3 glass walls, one drywall wall, bare concrete floor, and corrugated deck on the corrugated ceiling.
It's a lot of hard surfaces.
It's a lot of hard surfaces, and it's a cube. It's basically a cube.
Right. Which is pretty much the worst possible starting point for room acoustics. It basically allows sound to bounce all over the place. So what we did in this room to acoustically treat it, and this was actually with the help of Graham and his company, Music City Acoustics, was install 6 ceiling cloud panels that are essentially like 2x4 construction or something like that, that hang from the ceiling, and they absorb sound as they're reverberating in the space. So 6 ceiling cloud panels that are hung and 2 panels on the wall that are about, I'd say, 2 feet by 8 feet or 2 feet by 10 feet roughly, just to give you an idea. And, fairly unnoticeable in terms of the visual implication of it, but very, very noticeable in terms of the acoustic implications of that. So I think what we'll do now is jump over to our untreated room to give you all an example of what this room was like before it was treated. Go. All right, now we are here in our lunchroom, which is right next to our conference room. And as you can hear, a lot of echo. How's it going, Rob?
It's really a surprising difference. Because like you said, the panels that you installed in the conference room they're not noticeable.
Right.
I mean, they're hidden in the ceiling, they blend into the wall.
Yep.
But it's so loud in here. If a train goes by, it comes in and then it like reverberates.
Yeah, and that's something that if you can understand what we're saying right now, because speech intelligibility in this room is not as good. You can't hear what the other person is saying as well. And this is especially important in public gathering spaces. We talk about this on the episode with Graham. You need to be able to hear what people are saying, but the other aspect is when a sound sort of enters that space, like a train passing by our office, which happens very frequently, it will be louder in the space just because it's reverberating more.
Or if there's a meeting going on in the conference room and we're sitting in the lunchroom eating lunch.
Exactly.
You can hear people talking in the conference room louder than the person across the table from you.
Right.
It's weird. It's weird.
Yeah.
Yeah.
And it all leads to frustration sometimes and just, again, bad acoustics. So I think the last demonstration I'll do is sort of try to represent what reverberation actually is by applying a transient sort of sound, a very defined noise, and that will be me clapping. And what you're going to hear is the decay. And this is what's so critical to room acoustics, is the decay of the room. That's what reverberation is. That's what you're hearing, and that's what translates to an environment like this, an acoustical environment like this. So without further ado, here we go. And that's reverberation. Before we begin our episode, I'd like to encourage you all to check out the Passive House Accelerator. This is an online community and media company dedicated to accelerating the transition to clean, resilient, zero-carbon buildings. Among many things, the Passive House Accelerator hosts live online educational gatherings, puts out YouTube videos, publishes a magazine twice a year, hosts the Reimagined Buildings Conference series, and even has their own podcast. To learn more, please visit passivehouseaccelerator.com. I wanted to kind of start at a somewhat high level and I guess more of the basics about room acoustics. So, when we talk about room acoustics, what are we actually referring to, at least in your eyes? I mean, I'm sure it's somewhat subjective in terms of the interpretation of that, but what did we mean when we're talking about room acoustics in particular?
Yeah, I think there's typically like kind of what we encounter is there's sort of two main things that people have in mind. Kind of like what we've been talking about so far is like, hey, the room's too echoey or it's too reverberant or it's too loud. Those are the most common things for like restaurants. Normally It's noise. Like how loud is it? Reverb and echo are the things that can often contribute to how loud a space feels. But, so there's like, is the room comfortable to be in? Is it a productive space? If it's a music space, whether that's a recording studio or church or a venue, like can you actually hear the band with enough clarity and detail for it to be an effective space for that purpose? And so that's kind of how does the room actually sound. So that's for like the internal room acoustics. The other thing that comes up a lot is soundproofing and isolation. And so those are the two, I'd say, like main buckets that when we're talking to people or if people are thinking about acoustics, soundproofing is probably the most common term used. Yeah. That can often be used sort of interchangeably of like, hey, we need to soundproof this space so that it is a better conference room, so that we can actually hear people and have a high level of clarity. Or it can mean like, hey, there's too much noise coming in from the office next door. And so from a more technical perspective, like that's more of the correct use for soundproofing. Soundproofing refers to like, how do you prevent one sound from traveling through a wall or a barrier to another one? So like isolation, soundproofing, those are sort of interchangeable. And then like room acoustics is how the room actually sounds. Those are probably the most two common areas where if people are thinking about it, that's kind of, where they're going or what's the potential issue or problem that they're trying to solve.
Yeah. It seems to me too, like from my experience with acoustics, a lot of people or most people think of the soundproofing, the keeping the outside noise out as kind of the main focal point, but don't recognize that just the characteristic of the room itself has such a big impact on how it sounds. And I think just treating a room from a room acoustics from an internal standpoint, can have such a big impact that really has very little or nothing to do with keeping outdoor noise out. So as
absolutely.
Our conference room, for example, obviously has excellent interior room acoustic treatment now to make it sound comfortable from a less reverb standpoint, less echo. Speech intelligibility is much better in there. But we're right next to a train line, and it's a diesel train. So the thing is super loud, and it still really gets noisy in there. So as an example of, you can have one and not the other in terms of isolation and room acoustics.
Yeah, and treating a room is certainly not like a replacement for like proper isolation and soundproofing techniques, but those are almost always construction based. There's very little that you can do to improve, soundproofing or isolation in a room without building a new wall or tearing apart HVAC systems or replacing windows or something along those lines. It's a pretty reliant on how the space is actually built. But even if you have a train going by and that train's running by an office that's super reverberant and echoey, that's going to be a lot louder. When you treat that space, our perception of like how loud that train is within the office changes pretty dramatically. You're not stopping the sound from coming into the office, but you're changing how much of like a nuisance it is or how distracting it is and how much it actually impacts your ability to use that space well. So certainly not like a replacement for soundproofing, but in the right situations or circumstances, it can make a really big impact and potentially reduce the need for like how much soundproofing is actually needed, or is it necessarily, to build a whole new wall and change the whole structure of the building?
No, that's a great point. Like by cutting down the echoiness of the room, while it helps reduce the echo from noise generated or sound generated within the room, like a person talking, it also reduces the reverberation and echo of the outdoor noise that finds its way into the space. So it can have a kind of, that's a really good point. Definitely super interesting.
Yeah, and I might be getting a little ahead of ourselves, but that's also something that like will show up on testing. So like if you take you're testing a structure or a wall, a wall system for like STC ratings to see how effective it is at reducing sound transmission. If you have a speaker in one room and then on the other side of that barrier or that structure there's a microphone and you're testing to see how much sound is traveling through the structure. If you treat the room where that microphone is, you will have a better STC rating.
Interesting.
Because less sound's coming into the room, but because that sound, once it gets into the room, is quieter.
Gotcha. So is there, when testing for an STC rating, which is about how much sound transfer does it mitigate or prevent for sound traveling through a surface, is there a specific standard for the room that it gets tested in terms of treatment? In other words, does the room have to be treated to a certain level to ensure that the results are not skewed one way or the other based on the room treatment's impact on that?
That is a great question. We don't deal a lot with isolation, so I don't know the answer to that. I don't think there is, though. Most of the space, oddly enough, like from our perspective, I started in the music industry and was a recording engineer, so like my background is very music heavy.
Right.
But a lot of acoustics is bigger picture actually has very little, if anything, to do with music. So most of like the STC ratings or standards for, there's all sorts of codes and standards for apartment buildings and office buildings and how much sound can come in and out of those, based on if they're close to a freeway or something. So a lot of like testing, STC related testing, so sound transmission coefficient, those things have a lot more to do with that side of things and are entirely isolation based. But most of those spaces wouldn't really have treatment in them in the real world.
Oh, right.
If you're talking about like an office space, it wouldn't. So I don't definitively know the answer to your question, but I don't think there is from what I've seen.
Yeah, no, that's a good point. One thing that I think is also maybe helpful to clarify is the term that I think a lot of people are aware of, have heard of in decibel or the dB reading, one thing that is important for folks to know up front is that decibels are measured on the logarithmic scale. So an increase of 10 decibels essentially is a doubling of the perceived volume of that sound source. So, from if you have a reading of 50 decibels and you go up to 60 decibels, when you look at it from a number basis, might think we're only going up by 10 or 15%. We're actually doubling or going up by 100% of what you were at previously when you're at the lower decibel level. So decibels are tricky from that standpoint alone. But can you just speak to the decibel reading and, maybe misconceptions around it and how that pertains to just what we deal with on a regular basis from an acoustic standpoint?
Yeah, absolutely. And one thing is like you were spot on there with the, it's a logarithmic scale, so it doesn't change normally.
Right.
If something increases by 10 dB, our perception of it is that it has doubled in volume.
Okay, got it.
In terms of the actual energy that's there, it's more than tripled in volume. So like every 3 dB is a doubling of the amount of actual energy. We don't hear, our ears are just not that sensitive, so like we don't hear that as it also sounding like it's twice as loud to us, which makes it more confusing. That matters a lot more so from like a testing standpoint, but also, again, going back to like kind of codes and things and workplace safety.
Right.
While if you're looking at like OSHA standards or whatever it is, like workplace, or anything along those lines of like what levels or what dB, could you be exposed to? Those would go more so in like 3 dB increments because it's a doubling of energy and how that correlates to time.
Cool. So as far as, I guess, the other aspects of room acoustics in terms of the metrics before we move on, can you just speak to what reverberation is, reverberation time, and those metrics, how we use them?
Yeah, absolutely. So reverb time, or RT60 as it's kind of commonly known.
Okay.
There's also T30 or RT30 and T20. So they're just different time constants. So 60 corresponds to how long does it take, a sound. If you were to clap in a big empty room, like how long does that sound take to decrease by 60 dB?
Okay.
Or if 20 is your time reference, how long does it take for that sound to decrease by 20 dB? That in acoustics, in like room acoustics, how does the room sound, is a really important measurement, and the one that we kind of rely on the heaviest because it best correlates to how we experience the room. So we can infer and deduce a lot about a room based off of its reverb time. If it's a restaurant, we know we want that reverb time to ideally be below 1 second.
Yep.
We're not as sensitive to, it varies from space to space, but like we're not necessarily that sensitive to how loud the space is within reason. Like nobody's going to want to sit in a restaurant that's got 130 dB,
blasting music,
just constant sound level. But in general, within an acceptable range, we're not that sensitive to it. We're much more sensitive to the reverb time in that space and, how much sound is bouncing around the room and reflecting off of all the walls, because that really then correlates to how well can you hear the person like you're sitting across the table from. That's true if it's a restaurant. That's true if it's a conference room. Same thing kind of applies for churches, like we were talking about clarity or speech intelligibility. If you have a really long reverb time, you're going to have a lower level of clarity. And clarity is also a measurement that is actually used within acoustics, and it sort of breaks down or gives you a ratio of like the amount of direct sound that you hear to the amount of reflected sound. And that means, if I'm talking and there's sound coming directly out of my mouth, how much of you, like as the listener, the person that I'm talking to, do you hear that's coming directly from me and going straight to your ears versus how much of that sound is being reflected off of the walls or the floor or the ceiling and then coming back to you.
Right.
And so ultimately, reverb time is just like a great way to quickly capture and understand, is the room going to be well suited to its intended purposes? And that's really come together through a lot of testing that's been done throughout like the acoustics community over the, years and years and years now, and establishing kind of a framework or guidelines for, hey, if it's a church, then it's got a full band and a more modern contemporary service. Here's sort of the recommended reverb times for that space, depending on the size of the room. So it does get a little bit more specific. If you have a huge room versus a smaller room, that can be a factor. But same thing applies for, a church with like a full a cappella church, or a church that's got a choir and a piano or organ accompaniment, or a conference room or a classroom, recording studios, television studios, all of those things have now, published recommended art reverb times.
Cool. So that's I think a good summary on some of the technical basics. Now, I want to kind of just hit on this concept of good versus bad acoustics. So, to me, it seems like when you think about anything really on a good versus bad basis, it's very subjective and dependent on the person's preference. But is there certain aspects, and let's maybe focus on like a public gathering space, maybe as an example. So like a restaurant or a brewery or, any space like that where you would say there are characteristics that can make that room acoustically good versus acoustically bad. What sort of things would make it worse?
Yeah, absolutely. So a lot of like what we were talking about with reverb time.
Yeah.
Those things come into play, but there's a lot of rooms where we won't actually like take reverb time measurements. We can do projections of it.
Okay.
Because you can calculate it based off of like what the room materials are. But ultimately, a lot of it is subjective. So if we're taking like an event space or a brewery or a restaurant, first and foremost, if we're working on it, I want to know, what is the goal for like how they want the space to sound.
Okay.
Restaurants have a pretty wide array of, I guess, like the vibe and the atmosphere and the feel that is, that the owners or the managers of that restaurant would want to have in there. Some places are really quiet and intimate and romantic.
Yeah.
And other places are a lot more rambunctious and louder and energetic. And, obviously everywhere in between that. So that would dictate a lot of what is actually needed or, required to get to that point. But then within that, a lot of the things that we were talking about earlier, like how loud does it feel when you're in the space? You don't want it to be uncomfortable to where you can't hear, in a restaurant or a venue or a meeting space. It's really important that you can go there and experience the food or the event together with your friends or your family or whoever you're there with. And so communication's crucial to that, like being a, positive and fun night in a place that you might want to go back to. So you need to be able to hear the people that you're there with and be able to communicate with them clearly. And if you're at a restaurant, being able to communicate with your server is super important. And also just for like the staff at the restaurant, for the servers to be able to communicate with each other, for that to be a, comfortable and productive work environment for them, how loud it is, how well they can communicate. Those are the things that like first and foremost I would look at.
Okay.
And then you get into like background noise. So, is it in a really loud restaurant that's really reverberant? It oftentimes you'll be able to hear like somebody all the way across the room better than you can hear the people that you're sitting next to.
Interesting.
Because that sound just like, you get one loud person in the restaurant and their voice just like carries all the way across the restaurant. Right. And then everybody that you're sitting close to, their voice just kind of gets washed out by all of the reflected energy in the room. So I think in terms of characteristics of like what's a good space, it's really understanding, well, what do we qualify as good for that specific space? Because it is subjective to some extent. And then, making sure that it sort of fits within that so that it's not too bright and harsh and fatiguing.
Yeah.
You have good communication and clarity. And that it's comfortable. I think that, I think that's a big part of it, is having a comfortable space that people enjoy being in.
Right, and it's so much of it does come down to comfort at the end of the day, and that's there's certainly testing and all sorts of technical aspects of it, but at the end of the day, it seems to me like just people are more comfortable when the acoustics are good in a space versus less comfortable when the acoustics are bad. So yeah, it's so related to comfort. And when you're, on a project like that, or, if it's a restaurant or, some sort of event hall or public gathering space, you mentioned, sometimes you need to take measurements. So how can you just describe the process for identifying problems acoustically that need to be treated or should be treated, not just with the ear and the perception of it, but also with any sort of data that you might be collecting, how that process sort of typically unfolds? Yeah.
So there's a few ways you can go about it. And the first and the most scientific way would be to actually go into that space and take measurements of it. So you have a speaker, a sound source, and a measurement microphone, and that speaker will play a sound. A microphone captures that sound, and then through that, there's software that can analyze how long did it take for that sound to decay? So like record the reverb time measurements for it, but also the frequency response measurements for it. And then depending on the software you're using, you might also have a clarity measurement and there's other ways that you can look at it. So there'll be an impulse response of the room, which shows like reflected energy over time. Doesn't show any frequency information. And there's a few different ways that we can then look at all of that information within that software. So you can get quite a bit from it. Sometimes that's really helpful. Sometimes, from a like, how do you make the room sound better? It's not that informative. It kind of depends on what you're doing. And so our approach to most spaces is actually not to take measurements that often, because so much of it is subjective, but also a lot of it comes from real world experience of like knowing what's going to work, what's going to make an impact to that space. And for us, as a company that makes acoustic treatments and works on people with like their designs and recommending what they need, most people are coming to us with a problem.
Yeah.
So it's not like they're like, hey, we might have a problem. It's like they've identified the space is too loud, or it's
already
not comfortable, or
problematic.
it's too bright, or we can't hear anybody.
Right.
And the solution to those things is normally pretty simple. It's just a matter of like, how many square feet of absorption do you need?
Yep.
How do we, change the way the room sounds, and where does it need to go? And if you take measurements of it, rarely without like doing multiple iterations of here's where this needs to go, or let's try putting it here and doing different things, it's not going to tell you that much. Measurements are a great comparative analysis tool. They're not necessarily the best diagnostic tool. Okay. And we can also project a lot of that. So like I was talking about earlier, if you know the dimensions of a room and you know the building materials that were used, so are the walls drywall, are they glass, are they a combination, are they wood, what's the floor made out of, what's the ceiling made out of, we can put all that into a reverb time calculator. It's not like 100% accurate because it is a projection, but you can calculate based off of those materials and the size of the room and the square footage what the reverb time would be. And then you can also calculate what the reverb time would be with various amounts of acoustic treatment.
Gotcha. So moving on to sort of the treatment side of it. So, this is obviously what you work on a lot in your day-to-day is really the treatment side of room acoustics. So let's stick with the restaurant brewery example. So let's just say we have a very echoey and a lot of reverb in a space, and you're trying to come up with a treatment plan.
Sure.
What specific solutions would a treatment look like for a space like that?
Yeah. So most things in most of the things that we've talked about, most of the acoustic treatment would be absorption, sound absorption. So an acoustic panel, most often those are fabric wrapped panels with insulation material in there of some kind that absorbs the sound.
Yep.
And then those can be made in different styles or depths. So the greater the depth of the panel, you can go from 1 inch to 2 inches to 4 inches to 6 inches and so on. Mm-hmm. The deeper it is, the more effective it's going to be at low frequencies. In a brewery or a restaurant type setting, that is rarely a space where we're super concerned about lower frequencies because we're mostly dealing with speech.
Yep.
And the human voice will probably start around 150 hertz or so for men with like lower voices or women with lower voices, but then it goes up and continues on up to the frequency spectrum, and we can hear from 20 hertz to 20,000 hertz.
Yeah.
If we're just dealing with speech, the biggest concern is really kind of like 300 hertz and up. And so you can accomplish that with a pretty thin panel. So then in a restaurant or a brewery setting, we'd probably be using like a 2.5 inch or a 1.5 inch thick panel. So like our high, mid, or low profile panels.
Okay.
The area where that might change is if they had a band or if there was a lot of loud music and they wanted to treat at least one area of it for that, we might go with like a thicker 4-inch panel there.
Yeah.
But otherwise it is sound absorption, so sound panels or acoustic panels. And then first and foremost, we look at the space. What are the dimensions of the space? What does it look like? What's the layout of the restaurant? And what are the surfaces or what are the walls made out of? What are the ceilings made out of? And are there larger contributing factors to the space being too loud or uncomfortable or having a longer reverb time than we would like to? We target those areas first.
Okay.
If it's got a big vaulted ceiling, that could be an area that's going to be largely contributing to the way that room sounds. In any space, the most effective approach to treating it and the most efficient approach is going to be to treat multiple walls and the ceiling. So from like a purely numbers standpoint, you can make a larger impact with less square footage by putting it on the ceiling and all 4 walls.
Got it.
As opposed to if you put like even you to make the same change or adjustment to the room's reverb time in that case, or how the room sounds and feels. If you were just treating one wall, it would require a lot more square footage or a lot more acoustic treatment. That's not always an option, depending on the space. Sometimes it's like, hey, we can only treat the ceiling, or we can only treat this wall or these two walls. And
right.
those are certainly limitations that you can work within. But from a big picture perspective, the most efficient way is to treat as many surfaces as possible. You don't need to cover all of them typically. And so in the restaurant or the brewery, we'd look at, like I said, the size, the space, what are the walls made out of? And then look at, there's a lot of factors there. What's the seating made out of? Is it wood? Is it upholstered? Are there soft materials in there that are already helping to absorb reflections off of the floor or the lower portions of those walls? And then where can we make the biggest immediate impact?
Right.
And how we make the biggest change while, hopefully needing to put in as little treatment as possible so that you're not affecting the look and the feel of the restaurant in a way that has any sort of negative impact. And if anything, hopefully we're kind of adding to that.
Right. I think one thing that I've heard from folks before too is just, can we put a carpet down or a rug down, or is it, if we just put a soft surface on our floor, does that solve all of our problems? And it sounds to me like it's much more detailed than that. And it's, while it might help in certain regards, it might not actually address the key issue of things like speech intelligibility and areas that you might actually really be concerned about.
The short answer is yes, potentially, I'd say.
Yep.
But what ends up happening most often is that, if you put carpet in like a restaurant or a brewery, you're probably talking about something that's like an 1/8 inch thick or less, and it's glued directly to their substrate or concrete, wood, whatever the subfloor is. That does very little to absorb sound. If it's like, a plush high pile carpet that you have in your house, that's going to make a much bigger difference. And this is actually one of the areas where frequency response can be a bigger factor in this, of like, if you put a really thin carpet in your space, you are going to absorb quite a bit of high frequency information, but it's going to be really high up. So you're, probably 2,000 to 4,000 hertz and up, you might absorb quite a bit of it, but everything below that you won't.
Okay.
And if we're talking, the human voice, like for reference, this is always, I think, a fun way to think about it is like phones. I don't know if they still do, but phones used to only be able to like play back 300 to 3,000 hertz. That was all you needed to clearly understand somebody, recognize their voice, and be able to have a conversation with them. So that's kind of like the most critical area.
Right. Okay.
And our ears are actually the most sensitive to mid-range frequencies. If you put thin carpet in there, it's not going to do anything to any of that frequency range in a significant way. So the room's still really loud. It's going to still be muddy.
Yep.
And you have carpet, which could be a good thing or could be a bad thing, depending on what the space is and what you want it to feel like. So sometimes it can be helpful, like in an office setting, that can certainly be a positive factor in how the space sounds. And we worked on a lot of spaces where they're being renovated.
Okay.
And they used to have carpet and they're pulling it out, and then the space sounds really different.
Interesting.
So it can help, but it's very dependent on what the carpet is and how thick it is, and how much you need it to do.
Got it. Cool. So I kind of want to move on to just some common examples. So good common examples that I can think of. We've already talked to sort of the acoustics of what a potential public gathering, restaurant, brewery type space might be. An open floor office as an example, and you mentioned this a bit earlier at the top regarding how in certain situations in an office you might actually want some level of noise to help mask talking from other neighboring colleagues and things like that. Can you just speak to, just as far as offices are concerned, is there specific examples or situations that you've had where you've had to look at an office, and is it purely about just the noise floor, or is, do you want to control reverberation time? Are there similarities to the restaurant example that you can draw, or where might an office be maybe a little different?
In a lot of ways, they're pretty similar.
Okay.
From the standpoint of like, how do we, if it's an open office, you don't want sound traveling throughout the whole space and bouncing off all the walls.
Yeah.
You want people to be comfortable and be able to focus and feel, like they have some privacy, so they're not tired all the time and fatigued and not being super productive. And also, the idea of, I think the kind of large underlying idea of open office is that they're a collaborative space. if they're not a comfortable space to be in, though, people put headphones on, they kind of close off, and it goes from what would be like a great way for you to work with your team and communicate and collaborate on different projects into people actually getting more isolated, with headphones on, without like kind of hunkering down in their own little space. So there's a lot of factors that contribute to making an open office really effective, and acoustics is a big part of that. And so, like I was saying, you don't want sound bouncing off all of the walls kind of freely and creating a space that's just really loud and uncomfortable in general, because loud spaces aren't great for us to be in all day.
Yeah.
But also it changes how we communicate. So going back to like the background noise, you don't want it to be super quiet either, because then you hear absolutely everything that's happening.
Right.
And so you need the kind of this happy middle ground of like, there's some background noise, so you don't hear the slightest little, every time your neighbor moves their chair and you get distracted. You don't, those things we don't necessarily want to be aware of or know that they're happening. But you also want to be able to communicate without it traveling all the way, down the office space. So the way in which that's most often accomplished is, kind of a twofold approach with acoustic treatment, depending if needed. All of this is relative to like, what does the space sound like? So if you had carpet in there, if you had a drop ceiling in there, you may not need acoustic treatment, because drop ceilings are actually a great form of acoustic treatment.
Interesting.
They tend to be a lot less common, I'd say, in designs, at least that we see these days, just from I think largely aesthetic choices and more modern approaches to having things look more industrial or more contemporary, and what's the ceiling made out of it and that kind of thing. But they are a really good acoustic treatment option. Those can be implemented really well, and then you could use acoustic treatment. You don't need 100% coverage of your ceiling, so acoustic treatment provides another option where you can still have the more modern contemporary look, or keep all those building materials that you want in the space, and then treat it within that without covering 100% of your ceiling or your walls with it. So in terms of like how you would treat the office, really kind of a best case scenario, or depending on what's needed, acoustic treatment and then sound masking potentially.
Okay.
The one thing I would say in that regard is that I've seen a lot where people start with sound masking. And in order for it to work really well, it needs kind of a specific set of requirements, because you don't want too much background noise. And if you have a really reverberant space, you're going to end up having to turn the sound masking up really loud. And then you're going to start to exceed those background noise thresholds that you want to have like a comfortable, productive workspace or an office space. And that in and of itself can become distracting or problematic. So you really need the right setting for sound masking to work well, where reflected energy isn't just bouncing freely all over the place. It works much better in conjunction if you don't have a lot of reflected sound coming off your walls and your ceiling, and so then everything more close to you is being masked by that sound, but the sound also isn't just traveling, speech or anything that's happening isn't traveling throughout the office. So it can get, I guess, it can get a little complicated, but ultimately, it starts with what's needed. Same thing in the restaurant, and then within the office of, I might be a little biased, but I would say based off like what we've seen and having worked on a lot of offices where they started with sound masking, is I would start with the acoustic treatment.
Yeah. Okay.
Get the room itself sounding good, and then if the sound masking is needed, implement that. That will always allow you to have it be quieter and less of an actual background noise, but also be more effective.
Okay. Now, in your experience, do you find that room acoustics as a priority for designing a space? Is this something that is addressed in your involvement in any projects before they're actually built, or is it mostly or more frequently related to projects and spaces that have been in operation, maybe have a problem, they've identified, we've gotten a lot of complaints acoustically and we need to fix it? Do you see any upfront planning for acoustics other than in a studio environment?
Occasionally, yes. Not a ton. And I'd say it's probably the first thing that gets cut on office or restaurant projects, or even churches. It's through the build process, it might have been included at the beginning. And then I think, we're so, as humans, we're so visual in terms of how we think about a space, or, how we think we experience the space, although acoustics actually has a huge role in that. But if you're looking at plans or drawings, it's definitely the thing that most often gets either overlooked or cut first. And oftentimes it's not included in the design process. It is occasionally, and it's certainly something that can be, like we were talking about, you can project and calculate your RT60 times and your reverb times. So those are things that you can look at and say, hey, here's what we're putting together. Here's how many people are going to be in the space, because you can account for the actual number of people, like in a restaurant or in a church or in an office, because we absorb sound energy.
Yeah.
And you can project those things before the room's ever built, and that can be really useful, but it doesn't happen a ton. And certainly for like the projects that we work on, even on the studio front, we work on a lot of home studios. We don't, we do work on larger studio spaces, but there just aren't that many, particularly like this day and age in the music industry, there aren't that many big studio facilities being built.
Right.
Those ones, 100% acoustic treatment is a huge part of those designs.
Yeah.
From the get-go, because those rooms have to sound right. But a lot of studios these days are, somebody's spare bedroom, or they've turned their whole house into a studio, or they took over some, existing space that wasn't purpose-built to be a studio and then are retrofitting it. So in those cases, it also wasn't, planned out from the design stage or from the build process.
Yeah.
And so most of what we work on is sort of, hey, here's the space that I want to turn into a studio, or here's the restaurant that we're struggling with, or the conference room that we're struggling with, or the open office space that's like too loud, and what do we need to do? And so most of the time it's already built out and we're working on it, or making recommendations after they're in the space using it, kind of experiencing what some of the struggles are. But occasionally it is done earlier on in the design stage, and it certainly can be, and that's, I think, a great way to go about it.
Gotcha. Cool. So I wanted to move into just frequently asked questions, or things that I know I've heard a lot about from an acoustic standpoint. But one thing that I wanted to just ask you about, Graham, was just, are there any misconceptions about room acoustics that you constantly come across, or I don't want to say myths, but just common things that maybe are misunderstood, or misconceptions that you can think of that might be helpful to clarify, or at least talk about?
Yeah, I think the biggest one we touched on earlier, which is like separating soundproofing and isolation from room acoustics.
Yep.
Like acoustic treatment is people often will like search on Google or call and ask about like soundproofing panels. And while they can't, like we were talking about, they can have a positive impact on like how loud the train is inside your office. And that kind of thing. They're not actually like soundproofing or isolating the room from another space. So that's probably the biggest misconception, I think, is just like the terminology. Not a hard thing to sort through and figure out, what are we actually trying to accomplish in terms of like, is the room too echoey and reverberant or too loud, or do we actually need to stop sound from coming through the wall? But that's probably the biggest one. And then outside of that, there's not, I think, like within most spaces a ton, other than maybe people think there's not a lot that you can do or that would be that effective. I went to a wedding a few years ago, and the venue that it was at was pretty terrible sounding, and I reached out to him afterwards and was like, hey, if you guys ever want to do anything, we'd be happy to help.
Right.
And the response I got back was, well, like there's nothing that we could really do, and so dependent upon the PA and how the band sounds, and that's not that really couldn't be like further from the truth. It's like, if the room sounds good, it just means it's that much easier for any PA system that you put in there, or any band to be in there and to be set up for success. It's, the speakers don't really dictate what the room sounds like. They can have an effect on it, particularly with more complex speaker systems that are like more permanently installed. Now you can do a lot of amazing things with them, but by and large, like if you get the room acoustics right, that room will sound good if there's 2 people in there talking, or if there's 200 people in there talking, or a full band playing, because the room has such a big impact on what we hear. So I think just the idea that maybe you can't do anything in certain spaces, or that it's going to be really hard and challenging, would be the other thing. Within the studio side of things, there's a million, I think, myths or kind of things of like what you need to treat or how to treat it. There's a lot of stuff on that side of things that is wrong.
Cool. So the last thing I wanted to just quickly ask about was if we could just take a quick snapshot into HVAC noise, because I know that's something that oftentimes is a focal point from an acoustic standpoint. A lot of people will notice a fan from a air handling unit, or a blower, or some sort of rumbling or a vibration or whatever that might be. So are there just general good practices or common solutions that you've come across from a just controlling of HVAC noise standpoint?
Sure. Yeah, I am by no means an air conditioning expert, so I'd say take everything I say with a grain of salt, but I think there are some like kind of underlying principles, particularly as it relates to sound and isolation and soundproofing. So the biggest thing when it comes to just like background noise levels and like how loud is the actual air conditioning, that's a big thing in studios, particularly like, more purpose-built ones, because you want to be able to record an acoustic guitar or a violin or a vocal without hearing a ton of air conditioning noise in the background. Probably the easiest thing to change or at least improve if you're building the space or have access to your ducts is to make the ducts bigger. So like in purpose-built recording studios or spaces where you need low noise HVAC, the duct sizes are really big.
Okay.
And then the runs are also really long. So you basically have a bunch of curves that you introduce.
Oh,
and that
interesting.
helps absorb any sound that's traveling, like if, sound from the unit itself to the actual opening, the vent or the duct in the room, that can help absorb that sound throughout the ducting itself. So you have a lot of extra ducting, just sort of like making, S turns throughout the space.
Yeah.
That's one approach. Like I was saying, oversized ducts, that's super important because that, it's oftentimes what we hear is the actual air traveling over the grate or over the vent on your duct.
Right.
If you make the duct bigger and if you make all of those, the grate or the covering itself larger, you have less air trying to force itself through a smaller space. And then therefore you have less sound coming from it. So that's actually a lot of the noise that we'll hear. So those are the two, I'd say, most common kind of approaches. The other thing, and then there's two other main things that I would say, like in office spaces from an isolation standpoint, duct layout and design is probably the biggest thing of not having, ducting going straight from one room to the next, because that's basically just a big open hole that goes from one office to the other, and it's a huge sound leak.
Right.
So it's a very easy way for sound to get from one room to another. That can make, the actual HVAC design in spaces a lot more complicated, but if isolation is a concern, that is a big factor in that of like, how is your ducting actually run from one office to the next? And then the other thing is just, I think, like the actual noise of the unit itself, potentially. It depends on where that is. If it's not right outside your window, that might not be a factor at all. If it is, then it comes down more so to like, what's the STC rating of your window, or how effective is your window at not letting
the soundproofing
sound in.
Yeah, exactly.
And then if it's like on the roof, there's a lot of sound isolation products that can actually like dampen the vibrations from the unit into the building. That applies to HVAC and all sorts of other mechanical things. And so, I think so much of it's just kind of design. And then, I think the first few things we talked about are more of the big picture, simpler ideas that are pretty easy to implement. And then everything else is kind of more downstream of reducing vibrations within the building, so you don't hear the actual rumbling of the unit itself or anything like that.
Right. We deal with this a lot on projects where we're working with design teams, and it's really, the devil really is in the details in terms of how HVAC noise is either created or amplified or just not absorbed. It really comes down to all aspects of duct design and layout, register selection, size of the ducts and lengths and all that. So it's not just about get the quietest unit on the market.
Everything from like a soundproofing and isolation standpoint is detail space. It's like, if you want a well isolated room, you pretty much have to build the room twice or use twice as much materials as you normally would, and you have to do it the right way. So it's like sealing every little crack. All the like putty pads behind your electrical outlets to make those as sealed as possible, and making sure all the sound leaks. So like the biggest ones are the doors and the windows and potentially HVAC. Doing all the right things and all the little things with all of those is hugely important.
Yeah, and it's interesting because I personally work on a lot of projects. Most of the projects that I work on are what we call passive house projects. That's the design standard, and it comes from sort of this idea of passive solar design from originating 70s, if not even earlier than that. But so much of that is airtight design. And the one thing that I've noticed on projects where typically energy efficiency is the focus with regards to that design standard, so many times people notice the acoustics and how quiet it is because of the attention to detailing on air sealing, because of triple pane windows in a lot of cases, and also, fairly thick amounts of insulation in the walls. So yeah, all of the devil in the details to get the energy efficiency to work also have these good co-benefits of soundproofing these spaces as well too.
Yeah, that's awesome.
Yeah. All right, cool. So, Graham, thanks so much for being on our podcast. Before we wrap up, I wanted to ask a question that we ask all of our guests. In your day-to-day in the room acoustics world, where do you think things might be 5 years from now? Or where do you think you see, what might you hope to see in 5 years is maybe another way to ask that.
So I think in a lot of ways it'll be pretty similar. And I think some of it's like industry dependent. So if we're talking about, office spaces or restaurants or studios, I think there's different factors, or airports or, different factors there. So like airports are, we didn't talk about them, but like an area where I, somebody who didn't have like a background in acoustics and started in the music side of things and got into it, it's always been fascinating to me now, like looking at airports that are like under construction or newer airports and older airports. If you go to like DFW in Dallas, just like rows and rows of ceiling panels, of acoustic panels. Most of them are falling apart at this point. I'm sure they've been there for like 30 years, but so like it's kind of the evolution of acoustic treatment of like, that's what it was. It's still largely what it is today of like fabric wrapped acoustic treatment. But now there are micro perforated wood panels, or metal panels, or, essentially kind of like fancier, nicer looking versions of drop ceilings to some extent, but also can be used as wall paneling.
Okay. Interesting.
So on the more high end finishing side of things, there's definitely been a lot of, kind of changes to, or different options in terms of products for that type of space, whether it's like a big lobby in a hotel or an office building, of using like I said, micro perforated wall panels, which is basically just a wood panel with a bunch of tiny holes drilled into it. That's an area where I think that we'll kind of continue to see things go, but that's more like, is more of the high end side of things, of like high end furnishings, really incorporating it into the design. Acoustic treatment in a lot of ways is pretty simple. You need like a sound absorbing material. So whether it's insulation, recycled denim, sheep's wool, all sorts of things are used these days. Some with like varying degrees of effectiveness, but fiberglass insulation and mineral are two of the probably the most common. Maybe we'll see a change in those materials in terms of like, more recycled, reusable, or green products coming into play there, more so than they are. But I think in large part, the main kind of focus of the industry in terms of like churches and restaurants and offices, the products will probably be pretty similar. And then on the studio side of things, I think they will continue to be fairly similar as well.
Okay.
There have been over the last several years more kind of the introduction of active low frequency absorbers or bass traps from a few different companies. And that's sort of the same concept of like noise canceling headphones, but for your actual room.
Right.
I don't have a ton of hands-on experience with them, but we have worked on a few rooms where we, had them in the room and we were able to test them with and without it. At this point, it's not something that I would say like a big game changer.
Okay.
That might, down the pipeline have a bigger impact on what can be accomplished. And that would be really beneficial in smaller spaces where you can do more without taking up so much square footage in the room for the actual treatment itself.
Right.
So I think, more tech-based stuff, maybe, but ultimately it is physics. And so it's like really, how do we interact with the physical world around us and how do we change what that sound energy wants to do? And so a lot of it is physical products still that, by and large work really well. So I don't know how much it will change in that regard. From a product standpoint, I think the one thing that's been really cool to see, and hopefully this will continue as a trend, is people becoming more and more aware of it. Having conversations about acoustics like we are, and implementing it in more and more spaces, making sure that open offices are, really productive and great sounding spaces for employees and the teams there. And coffee shops like Starbucks just announced not too long ago that they were going to, all of their new shops really focus on the way that they sound in hopes to improve order accuracy, but also the customer experience
Getting
and
names
the
right.
experience for their teams.
I'm sure.
So I think it really is becoming a bigger part of that process in terms of like the design process. And they're also going to retrofit, Starbucks is also going to retrofit some of their, existing stores and locations. So just seeing it become a bigger part of the design process and a bigger concern is great. And I hope, very hopeful that is a trend that we, continue to see.
Oh, very cool. Very cool. That's awesome. Well, thanks so much, Graham. I appreciate it. Go check out Music City Acoustics, and we'll provide resources and links in the show notes. And thanks again.
Awesome. Thanks for having me.
Buildings and Beyond is produced by Stephen Winter Associates. We make buildings better. For more info on this show and extra resources on the topic of acoustics, visit our website at swinter.com. Special thanks to our guest Graham, to Rob for joining me in the intro, and our full podcast team, Trisha Carr, Heather Breslin, and Ian Slackus.